In this video, we are going to start the topic laws of motion. Now, this is a topic you already are familiar with. You've studied about it in your class 9 and also in your class 10. So first of all, what we are going to do is we are going to do a kind of revision of some basic concepts like inertia, momentum, force, and after that, we are going to look into Newton's laws of motion. I'm assuming that you have some basic idea about these things, so we'll discuss these concepts in brief. Later in this topic, we are going to look at some applications of Newton's laws of motion, and also we are going to look into some newer concepts. So let us get started with inertia. Now you already know that inertia is the property of anything that has mass. However small a mass it be, or however big a value of mass it be, anything that has mass possesses inertia, remember. Because of which what happens is, if the body is in a state of rest, it continues to be in the state of rest. Or if the body is in motion, it wants to continue being in the same state of motion. Unless, of course, a force acts which makes the body behave in a different way. Behave in a different way meaning, if the body is at rest, like this eraser here, then the application of force changes the state of rest of the body to state of motion. That is, the body is behaving in a different way now. Also, if the body is in motion, then the application of force could change the state of motion to state of rest. That is, the body again is behaving in a different way. Now, inertia can be of two kinds, inertia of rest and inertia of motion. The tendency or the inherent property of a body at rest to continue in the same state of rest, unless of course acted upon by an external force, is what is called your inertia of rest. To give you a famous example, if you're inside a stationary car and say the car suddenly starts, what happens is you will lean backwards. That of course is possible because of inertia of rest. You can give a look at the other examples of inertia of rest yourself. Now let us look at inertia of motion. If a body is in motion, then its tendency to continue in the same state of motion unless acted upon by an external force is what is called your inertia of motion. Now here also I'm only going to discuss the most famous example, that is when you are inside a speeding car and the driver suddenly presses the brake, what happens is you will lean forward. You will move in the forward direction. You must have experienced that. So that happens because of inertia of motion. You can give a look at the other examples of inertia of motion yourself. Now we come to momentum, or more precisely linear momentum. Remember, any body having mass will possess linear momentum only when it is moving, that is, when it has a certain velocity. Now linear momentum is denoted by a small p. It happens to be a vector, therefore the vector notation here. So the linear momentum p is equal to the mass times the velocity vector. And the direction of momentum is the same as that of the velocity of that body, remember. So the momentum that you've studied about in your junior classes and this linear momentum, they are one and the same thing. The reason we are writing the word linear here specifically is because we are also going to study about something called angular momentum. So just to differentiate between the two, your momentum is now called linear momentum. Now I have these two questions for you all, wherein we have two balls A and B rolling. In one case they have the same mass but different velocities, and in the other case they have different masses m1 and m2 but they have the same velocity. So the question will be like, in the two cases it will be difficult for you to stop which of the balls and you need to give the reason why. And I'm telling you that you know the answer to these questions. So try answering these questions, and if any difficulty you have, you can let me know. Let us talk about force now. Force is an external agent which tends to change or actually changes the state of rest or of motion of a body. That is, if we have a body at rest, then a force acting can make the body move. Or if we have a body which is moving, then a force acting can bring the body to stop. Not just that, if we have a body moving with the same speed in a straight line, then a force acting can make the body move faster. Or if the force acts in a direction opposite to the direction of motion of the body, then the force acting can make the body slow down. Also, if a body is moving in a certain direction, then a force acting can change the direction of the body. So what is happening in all of these cases? What force is doing in all of these cases basically is that force is making the bodies accelerate. So remember, force is something that causes acceleration in a body, to put it in simple words. So remember, whenever you see force acting on something, you have to understand that the body will accelerate. When I say acceleration, I'm talking about deceleration or retardation also, remember. But in some cases, force only tends to change the state of rest or motion of a body, like when we are trying to push a concrete wall. So when we are trying to push a concrete wall, the force that we are applying is not enough to make the wall move. So in that case, force only tends to change the state of the body. Now, force can be of two kinds: contact force, non-contact force. I want you all to write the definition of contact and non-contact forces yourself and also give their examples. Let us also talk about this concept of uniform motion, or also called uniform velocity. Now, a body is in uniform motion means that the body is moving with the same or constant speed and that the body is moving in a straight line. Therefore, uniform motion is a case of no acceleration, remember. So if we see a body in uniform motion, you have to understand that the body is not accelerating. Get this idea very, very clearly. If we have a body moving with the same speed but is changing its direction, then that is not a case of uniform motion, remember. That's a case of non-uniform motion, and thereby a case of acceleration, remember that. Remember the famous question that you had in class 10, that a body is moving in a circular path with the same speed. Is it a case of acceleration? And the answer was, of course, yes. Why? Because the body was changing direction there, therefore it was a case of non-uniform motion, and hence a case of acceleration. But uniform motion is an ideal concept, remember. It doesn't happen in our everyday life. In fact, we've never seen it happening. Why? Because in our world, we also have dissipative forces like friction, which causes a loss in energy. So any moving body loses its energy because of dissipative forces like friction, and eventually the body will come to rest. Like this fidget spinner here.